elementary school. I used to build those science fair projects. I know about little logic gates that make decisions. I wonder if I could design a computer. And I shut my door. I didn't talk to my dad, who was an electrical engineer. I didn't talk to any friends. I just started working on dozens of sheets of paper, trying to draw out sets of gates, connected gates, connected gates, little diagrams that would add up and do the job of this computer. Didn't succeed too well the first time. Then eventually I got pretty much the guts of a computer on paper. Not a very good job. And then I did it over and over on weekends. I would close my door. And in 2 days I would get some new chip manuals. Chips were coming out. I had a little transistor radio, the gadget of my life. A little radio fit in my hand, and I could dial music. And I could go to sleep, listen to music all night long. And then my dad took me to a show in San Francisco, and a guy that might have been Gordon Moore, one of the inventors of the integrated circuit chips, showed me a diagram of a bunch of little buildings and roads connecting them, and what it was a chip that was going to have 6 transistors on one piece of silicon. Wow, the start of the chip industry. I got to witness it. How incredible. So I went to my dad and I said, wow, so now I'm going to have a better transistor radio, right? And he explained to me that these chips cost more than any human can avoid when they're new. And that basically only the military can afford them, because the military is making rockets, and saving a fraction of a gram on a rocket is worth the money. And so after a while, as the industry progresses, there's leftover parts, and that's what we normal Joes get for the appliances in our home life, the average person, you know, and those were the things that meant so much to me. And I just regretted it, that the military gets the good stuff, and our little products that we love, our transistor radios, aren't defining the state of the art. Well, look at where we are in this year. All of a sudden, the biggest, fastest chips in the world are made for personal computers, and now they're actually made for games. So the consumers want. The average Joe at home won the game. The military gets what's left over. That's true. It feeds back the other way now. I'm with a company, Fusion that's replacing hard disks with integrated circuits. Well, the chips are so inexpensive now because of iPhones and iPads and iPods that use so many of them worldwide that they're incredibly inexpensive memory. Okay, so I'm going along and I'm practicing this computer design. Well, I thought, where can I learn about more computer stuff? There were no books in the bookstores. There were nothing in the libraries that I could find in those days. And Stanford Linear Accelerator Center was the top physics organization in the world. Some of the brightest people in the world worked there. They would surely have books on computers, manuals on computers. So a friend and I drove down on a Sunday. This was a new place. And we drove in the Sunday, nobody stopped us, and we got to the main building, and I discovered that where the brightest people work, there always leave doors unlocked. Never once did we drive down on a Sunday and not find one door unlocked. And we'd get into the main building, go up to the second floor, and there was a library. And I could go through all these books and articles about computer topics, and I could fill out little cards, and they would send me a manual for that computer from Digital Equipment Corporation, a computer from Hewlett Packard, a computer from Varian Corporation, a computer from Data General. And I would order these computer manuals, and when I got them, at home I'd close my door on a weekend, I'd sit down and start designing these computers over and over and over. I could never afford the parts to build one, so I made up a game. And the game was compete with yourself, not with anyone else. You're not competing for a grade, you're trying to outdo yourself. How do you outdo yourself in a design? Fewer parts than last time. Clever use, looking and searching for other parts that were designed for one thing, using them for another. And clever little approaches. If I got a leftover part of one chip, can I use it for a function it wasn't designed for, to save one chip? And I got so good at this, and eventually my designs for all these little mini computers of the late 60s were getting to be about half the number of chips that were in the ones the company sold. So I knew I was getting good at this. Didn't have one friend I did it with. No teachers knew I did it, not my parents. I just did it for my own fun. That was my thing in life. The Data General Nova came out, and it was one of these old mini computers, and every computer, of course, had switches, little ones and zeros on switches, push a button, and those ones and zeros go into memory. And eventually you could load up memory with enough ones and zeros to have a small program. And then if you had very expensive devices, like a big teletype typing machine that cost as much as a car, pretty expensive car, connected to your computer, that little program you typed in could start reading in more programs from what's called paper tape with holes in it. And you could eventually get real programs that made sense into your computer. But it was a lot to it. This Data General Nova, I sat down to design it. It has strange architecture. Its architecture, instead of 50 different little instructions, one says add, one says add and shift left, one says subtract, one says store it in memory. Instead of having 50 little instructions, we had one instruction. And the 16 ones and zeros of that instruction, a couple of the ones and zeros meant which register do you use for one side of the adder. 2 more bits meant which register to use for the other side. 3 bits meant do you add, do you subtract, do you do what's called ORs, ANDs, exclusive ORs, all these logic operations. Another bit meant do you add a carry, a little 1, you add a 1 into it. Another bit meant do you shift it to the left, or do you shift it to the right. My gosh, I wound up just drawing wires over to the chips that did those tasks. Wound up being half as many chips as all my other designs. I was so impressed because I loved designing things with fewer parts. That was my goal in life. And here was a computer with half the parts doing just as good a job. So that became really a driving force in my life to always think about architecture when you're designing something, even a big program, knowing the components that you're going to build it out of very well, being a good builder, and designing it around those components. Don't just design it in the blind and give it to somebody else who knows the components to do the rest of the design of your architecture. So I just was designing all these computers, couldn't afford any of the parts, and I went to my first year of college. Had 800s on all the math and science SATs, and you'd think I would apply to some big technical school. For the first time in my life, I flew out of my state of California with a friend, 2 friends, and we went to visit the University of Colorado. Went to bed that night. It was Thanksgiving, it snowed. We woke up and they said it snowed. We opened up the curtains, there was snow. I'd never been in snow in my life. And I hate heat, but I love snow. I went out there and I just loved rolling around in the snow, probably in my underwear. And we're throwing snowballs, we're building snowmen. That was the only school I would apply to. That was it. And thank God my parents let me follow my heart. And so when I went to school, my first year, Introduction to Computers was a graduate level course. Can you imagine that? Graduate level. Because I was enrolled in engineering, I was allowed to take it. And I did get an A+. But I thought, wow, now I can write programs. You submit your programs on punch cards. You punch out the cards, turn in the programs, come back in a few hours, and then have your printout. I started writing programs to calculate, I had 7 different programs to calculate types of numbers, mathematical numbers, Fibonacci numbers, powers of 2, inverse powers of 2, and some other esoteric numbers. I had 7 different programs I would turn in 3 times a day, each time printing out 60 pages for each program, because that was under the limit that the computer would kick you off time-wise. So I was building up reams and reams of output in my dorm room for all these tables that scientists use, and I didn't realize that a class had actually anticipated a certain amount of use of the computer, and I ran our class 5 times over budget. They made it sound like it was going to be a lot more than out-of-state tuition. Very expensive school to go to. Let's see, I guess Colorado is #1 Playboy parties. Someone said it was them too. Well, so anyway, the next year, instead of going, that year, electronics has to be fun. You got to have fun in everything you do in life, and I really adhere to that philosophy, and I have my whole life. So I went down to Radio Shack and got their high-speed transistor and wrapped a little coil and put in some parts I grabbed out of a transistor radio, and I could tune up this little thing I called a TV jammer. And it would jam a black picture in our dorm room, But so I went over to the one dorm where they had a colored TV, Libby Hall, the girls' dorm. Went down in the basement and I sat in the back and I tuned it up and it fuzzed up the picture a little. A friend of mine sitting in the front row with no planning, Randy, whacks the TV. I made it go good. After a while I jammed it, he whacked the TV, I made it go good. So they started, after a while, they got the idea that this TV has something flaky. For 2 weeks, they stationed a person right next to the TV. It was his job to whack the TV until it went good. And then I started, in those days we had tuning controls. They would do the tuning control and go good. Pull their hand away, it'd go bad. And back, good. So they got used to where your body is. So I started playing with them like it was a psychology experiment. Not once did they think that one of the people in the back of the audience was playing. Not once did they ever suspect that. They would hold the antenna up, climb up on a chair, holding the antenna to the TV board. Put a hand on the middle of the TV and a foot on a chair. The last half of Mission Impossible. This was so much fun. People don't understand electronics. I never got caught once. I had my computer class that I described, and my computer class was about a third of the upperclassmen. They got to watch the professor live, and the rest of us had 4 TVs in our room. And so I built one of my little TV jammers into a magic marker pen. And I brought it in, it's in the rings of my little binder, and I sat down and I kind of jammed it up, and these closed-circuit TVs with the cable going into them weren't affected as badly. The one right above me was hardly affected. The one in the upper right hand of the room, man, that one was jammed the most. After 3 guys stood up in the front of the class, and they're looking us over. I didn't realize we had teachers in here. They're TAs. I was just going to turn it on, jam the TV, and turn it on. Now they're looking at us. I'm not going to reach down and turn it off. They start saying, whoever's got the transmitter, turn it off. Yeah, it's me. So I'm sitting there thinking, they're watching us like hawks. Eventually one of them disappeared, and the professor made an announcement on the TV. You could watch the show. It wasn't jammed that badly. But after a while, those TAs weren't looking at us closely, and I'm thinking, well, when everybody walks out, they'll never know who had it. I see a guy getting ready to leave the class early, and he's seated over by the TV that was jammed the worst, actually. And he's on that side of the room, and he's picking up his books. So as he walked towards the door, I kind of made it go in and out, in and out, in and out. When he left, the TV was perfect. The TAs pointed at him. So I learned, you can always get 2 jokes for one if you can frame somebody else. In my life, including when we introduced the Apple II, which led to the one time I ever saw Steve Jobs really laugh out loud. But that's another story I'm not going to tell today. Next year, my parents had told me they only had enough money to really send me to that expensive school for one of the first 2 years. And this next year I went to local community college in Cupertino, the end of college. A friend from high school had duplicated the key to the computer room. They didn't know. So we'd go in at midnight. To me, a computer is sitting there, an IBM 360 Model 40. It wants somebody to be feeding cards and programs in and running it and twiddling its internal circuits. We'd go in at midnight, and I'd work till 2, 3, 4 in the morning, running program after program through, and then we'd close up quietly and leave no evidence we'd been there. So that was it. I just wanted to run any program I could, any time I could take every class in the school, whether it had transfer credit or not. And after that year, I had my father brought me up very ethical. You tell the truth, you are who you are, and debt is kind of phony. You know, you should use what you have to buy things. And I didn't want to go off to a 4-year college and go into debt. So I went to work for a year, programming a computer. At a door that I walked into by accident and discovered they had a computer company in Sunnyvale. I walked in and I got a job, and for a year earned the money for my 3rd year of college. While working there, I told one of the executives that I used to design all these computers back in high school. And he said, oh, did you ever build one? I said, no, I couldn't afford the parts. He said, well, he had connection to the chip companies in Silicon Valley. He would get me the parts for a computer. I went home that night. I designed a small computer of my own design. I brought it in. He got me all the chips, even 256 bytes of memory chips, 8 memory chips from Intersil. And I was building it up down the street with my friend Bill Fernandez, and Bill said, you should meet this other guy that went to our high school, Steve Jobs, because he knows digital electronics, he's built devices, and he likes to play pranks at school, and I was the best known prankster. So Steve came over we're sitting on the sidewalk, and we're comparing the pranks we've done, and we discussed our technical abilities, and I think from that moment on, Steve Jobs never tried to do anything, build any technical device again, because, well, he was just outweighed. Well, you know, hey, heck, Steve wanted to be the most important person in the world. I want to be the greatest computer designer in the world. So, representation. Steve was very much a member of the hippie counterculture, and I was more an observing approver of it. I like people that think differently, and they have words and they have thoughts that you can't really challenge. They're thinking about different ways of life, but I'm going to be pretty much straight in the middle. But I appreciate them, and I had my long hair and hung around with them, but I just didn't do all their things like drugs and all. Steve was more like a real hippie, and he would have bare feet, hang around with the people that have nothing in life, at that stage in life. You know, he's about to go off to college, he's still in high school, and he would eat seeds, and he was a little further out on the scale of, you know, how they lived their life. So, but he had read books.